All right, and then the next issue about this question is, now if you remember I saying that all the bearings, they happen on the horizontal ground. All right, bearing, they are just on the ground level. But somehow in this question, they ask for the bearing of an elevated point. It is asking for the bearing of T from Q. All right, now, but T does not lie on the horizontal ground. T is an elevated point. It is a helicopter. It is above the ground. All right. So I think I didn't talk about it very clearly. I didn't talk about how do you measure an elevated point, the bearing of an elevated point, right? Now the thing is simple. For elevated point, if the point is above the ground, we cannot get the bearing directly. For all the elevated points, like point T, when you want to talk about the bearing, we always refer to the ground level. All right. So the bearing of T from Q, in fact, is a fancy way of saying the bearing of P from Q. All right. Is the ground point. We use the ground projection to measure the bearing. All right. So to find the reduced bearing of T from Q is just like to find the reduced bearing of P from Q. All right. That is the same applied to every elevated point. If the point is not on the ground, or if the point is beneath the ground, you dig 500 meters into the ground. All right. What is the bearing of the bottom of the pit? All right. That once again, we do not measure the bearing of those elevated or submerged points. We use the ground projection. So that would be using point P. All right. So this is just point P. All right. That is the same for all elevated bearings. And then, now this diagram is kind of like tricky if you look at the two-dimensional space, all right? Some student make the mistake that she thought angle PQR, this one is a right angle, all right? But I think it is stated explicitly in the question that angle PQR is an obtuse angle. It is not a right angle, right? Don't assume right angle or parallel lines if it is not mentioned in the question. This is, once again, a very important guiding principle in three-dimensional problems. Do not assume right angles or parallel lines or even straight lines, all right? If it is not stated explicitly in the question. Not so much about straight line, but right angles and parallel lines, all right? Because of the 3D perspective. So in order to help you to overcome this question, I want to provide you with another diagram like this. All right, this is a re-rendering of the diagram in question 2. All right. However, there's a twist in this thing. All right. In the diagram here, it is three-dimensional. All right, it's three-dimensional. So I hope that helps you better see the thing. Now PQR is on the ground level, as you can see from the side view. All right, PQR is on the same ground level. Can you see the thing rotating in this? I don't know whether you can see it, right? It's rotating on my computer, but I don't know whether it goes through the Zoom video conference. If you cannot see it rotating, please give me a note in the group chat, all right? So that I know, all right? No one is commenting, so I guess you all see the thing rotating, all right? So PQR is on the ground level, and if you watch it from the top, that is the bird's eye view, all right? If you watch it from the top, you see angle PQR is an obtuse angle. It is slightly greater than 90 degrees. It is an obtuse angle, isn't it? All right, it's slightly greater than 90 degrees, so you can see here. All right, and the directions, I put them in north, east, southwest. All right. So now T is an elevated point. T is a helicopter above point P. All right. So the diagram, in fact, looks like this. All right. So that is a problem in 3D perspective. Like I said, sometimes if the diagram is in this angle, it looks like that. T, P, Q, they are in the same straight line. All right. That's what I said. Don't assume straight lines. Don't assume right angles, even though they look the same. It look like a right angle. Looks like a straight line. It depends on the perspective because we are looking at three-dimensional objects on a two-dimensional piece of paper. All right, we are not at the time of like rotating items on a piece of paper. We cannot do this on a piece of paper. That's why I have to show you in the Zoom session. All right, I cannot print several perspectives of the same diagram. But now with this software, I think that can help you to understand the actual three-dimensional thing. All right, in your head. All right. Now, but that's the issue. When you are learning, when you are working with the homework, you can have this software tool to help you. All right. Later on today, I will tell you how you can also do this on your own. All right. I will share with you the files, and we'll tell you a little bit about how do you download this software. But the thing is, when you come to the examination, all right, so far, maybe 20 years ago, you are allowed to use computers to do the examination. But nowadays, you still have to have the ability to turn this in your head. Now, you can have all this computer and visualization to help you. But at the end, in the examination paper, it is still this. All right. In the examination paper, as of 2020, 2021, it is still like this. All right. You have to turn this thing in your head, like what I'm doing it here, right? But it's in your head. You have to tell that, well, it is a perspective thing, that the points T, P, Q, they are not lying on the same straight line. It looks like they are lying on the same straight line. But if you can see through the two dimension, if you can perceive the three-dimensional thing, you know they are not a straight line. They are not even on the same plane. T, P, Q, they are like this. All right. So that is the question. First of all, it's a 2D question. We get PR. All right. And then you use the angles to find the bearing of P from Q. So you have to think about which is the angle of the bearing of P from Q. All right. Is the angle around here or around here? Which angle shall we talk about? There are like 1, 2, 3, right, 4, 5, 7, so many angles in here. So which angle corresponds to the bearings of T from Q? That is the bearing of P from Q. Okay. So that is question number 2 in the homework. All right. Do you have any further things you want to clarify about question 2? Now then, likewise, I will show you the three-dimensional diagram for question 3. All right. Now this three-dimensional diagram is tricky, right? But the real life thing is very simple. You take an equilateral triangle, right? Now, mind you, a lot of information is packed in one single word, all right? Equilateral triangle. So somewhere in the equilateral triangle at the 2 cm point, I made a fold line, all right? I fold up this part into a shape and I put it on the ground level. So what does it look like in three-dimensional for this particular diagram, right? For this particular shape, right? So let me open that for you. All right. I will teach you how do you do that, right? I will give you the files so you can download these files and rotate all the things as you like it at home. All right. But let me remind you, at the end, you still have to have the ability to rotate this in your head. All right. All right. So that is the 3D thing, right? That is the piece of triangular cardboard. All right. The fold line is right here. This is the fold line, all right? So you fold up a piece of rectangular equilateral triangle, all right? So that the baseline and the point, the vertex here, they touch the same horizontal ground, all right? With a condition that this angle, the folding angle is 100 degrees, is mentioned here. Angle BDA is 100 degrees. Angle BDA will be this angle. All right, angle BDA. If you look at the three-dimensional thing, this is the angle BDA. All right, that is the angle BDA. That is this angle here. All right, BDA. All right, that is the angle here. It's 100 degrees. All right. Now, so that is an important thing. I saw your homework. Some of us submitted the homework. And I saw your mistake that some of us, not one, not just two, but quite a majority of us mistook this as a right angle. All right, if you look at it sideways, now you see. All right, some of us mistook this to be a right angle. In other words, they mistook that this part, this trapezium, is vertical on the ground. But if you look carefully, all right, you discover that this piece is not guaranteed to be vertical on the ground. It depends on the angle, all right? It depends on the angle that you fold up the triangle. Now try this on your own if you don't believe me, all right? Cut out a piece of equilateral triangle paper and fold up like 1/3 of the way, all right? And put it on the ground like this, all right? And then try to experiment, try to play with different angles of opening. There is only one sweet angle that will give you a vertical plane, vertical trapezium. All right, there is only one sweet angle that will give you this vertical trapezium. You may want to calculate for this one. All right, to calculate this one may be a level 5 challenge. To calculate the sweet angle that make this trapezium vertical. All right, but for an angle like 100-degree, like angle, where is it? BDA is 100-degree. The trapezium part is not guaranteed to be vertical. The trapezium part is making a certain angle with the ground level, as you can see here. All right. But now we are not asking for this angle. We are asking for what is the angle made by this small triangle with the ground. All right. So I'm not going to spoil the question, but first you have to ask the where question. Where is the angle that the small triangle is making with the ground? Identify the target triangle, identify the focus triangle, identify the target angle. All right. And then next up will be the what question. What is the size of that angle? 2 questions, right? One is the where question. Where is it? The second is the what question. What is the value? All right. Like I said, usually the second question is easier because we learn all about those solution of triangle, triple S to find an angle, SAS to find a line, all right, or even the SSA ambiguous case. That is about the what question. But what I want to focus today is the where question, all right. And just like question 2, all right, like I mentioned, don't assume right angles, don't assume parallel lines, don't assume straight line because they look like so, all right. Like this, right? There are 2 lines here, the base and top line and the bottom line of the trapezium. Are they parallel? All right. Now we can guarantee they are parallel because it is specified here, all right? It is the converse of the intercept theorem. Both are 2 cm for BD and CE. So we can guarantee the dotted line to be parallel to the baseline, all right? So unless you can prove it or unless it is stated clearly, don't assume parallels, don't assume right angles, don't assume straight lines, all right? Okay, so this is the diagram, right? I'm going to upload the diagram and tell you how to use this software. If you think this would be helpful for you to figure out your homework question, all right? Now to this end, I want to do 2 poll questions, right? For the where question to identify some of the items in 3-dimensional objects, right? Just 2 questions today, and then I will tell you how to work with this software, and then we can call it a day. Okay, so okay, so this is the first question, right? I'm going to do this polling again. All right. So here we have this right. Let me make it bigger. All right. Right. Can you see? All right. So we have this triangular prism, and then in the prism we have a diagonal AE. We have the line AE. All right. And we want to find the projection of the line AE on the plane ABCD. All right. Now no calculation. Just observe, all right? Just the where question, no calculation. Just tell me where the projection is, all right? So I'll give you the polling answer sheet right now. Okay, do you see this? All right, you will respond to it now. And I will see how good you are at spotting the line of projection. What is the meaning of line of projection? Line of projection means that you can imagine a light source shining above the plane, and the shadow is the projection. Okay, we have answers coming in. Thank you. It won't take you too much time, no calculation, just look, all right? Or you may want to twist the thing in your head, all right? I'm going to give you a 3D object so that I'm going to show you a three-dimensional software diagram, the object, so that I will turn the things in front of you visually. But now I want you to turn it in your head to see how good you are at finding these three-dimensional items, all right? Okay, 31 of us are respondents. So let me show the answer. All right, let me show you our result first. All right. So this is our results. The answer is D. Only half of us managed to get it right. Now that is I'm a bit worried about this. All right. It is the basis of the three-dimensional problem. Like I said, it is such a pity to learn all the calculation tricks only to calculate the wrong thing. All right. It is such a pity to learn all this calculation and spend all the time doing exam only to calculate the wrong thing. All right. So I stress the where question is the utmost important, even more important than the how question. All right. Try not to calculate the wrong thing right. Don't find the wrong angle right. All right. Identify the angle, make sure it is the target, and then you start the calculation. All right, given a choice, I would rather you master the identifying rather than the calculation. All right, if you can identify but you cannot calculate, at least you get the identification point. But if you misidentified and then you start all the calculation, not only that you will not get any point, but then you waste a lot of time in the calculation. All right, so now let me explain to you how do we get the projection. All right, for the half that missed the answer, and even for the half that get the answer, I want to share with you why do people arrive at answers like B and C. All right, for those who chose A, for the one who chose A, is is way out of the mark. It shouldn't be A at all. All right, it's okay, but let me show you the thing. All right, I hope that would be much easier if you can rotate the things in your head. All right, so let me show you this. This is the item in the question, right? Let me change to rotation. All right. So we are talking about the line AE. This is the line AE, right? Can you see it? Sorry. Okay, am I sharing it? Okay, so can you see this rotating? If not, please drop me a note so that I know. I hate to speak to air. I hate to speak to the computer with no one responding, right? So no response, I guess, is good for you. You can see this rotating, right? We are talking about the projection of the line AE on the plane ABCD. ABCD is the bottom graph, okay? The one in gray. Now, to talk about projection, imagine you are a bird, all right? Flying right on top of this plane. Now, this is what a bird sees. This is what the view of a bird from the vertical directly on top of the plane. The projection means that if you see the line AN is this diagonal here, all right? I mean AE, sorry. AE is the diagonal here, and AN is the projection. From the bird's eye, the projection and the diagonal, they overlap one another. That is the idea of the projection from the bird's eye view, all right? the line and the projection, they overlap upon one another. Or another way to state that is the shadow. Imagine you are the sun, all right? You cast the light onto this rectangular plane, and the shadow is the projection of the line, right? If you got the line AE, imagine what is the shadow of AE. Imagine what is the shadow of AE, all right, on the ground, all right? That is the second way to do that, all right? The first way, imagine you are a bird, all right? A bird will see the line and the projection overlaps. That is one way. Secondly, imagine you are the sun. You put a lamp right on top, directly on top of the plane, right? Of course, if the plane is sideways, if you are talking about this triangle, then you put the light here, all right? The light should be directly, vertically on top of the plane, all right? If you are talking about projection of AE on this triangle, then you put the light here, all right? You put the light directly vertical to the plane, all right? So we put the light on top here and shine the light onto the plane. And the shadow of the light will be the projection, all right? That's the second way. Now, there's a third way to understand the projection. There's a third way to understand the projection. Take the end point of the line, right? In this case, you take point E. We look at it from here, all right? Look at point E. We drop a vertical line all the way to the ground, what we call the foot of perpendicular. The foot of perpendicular for point E is point N, all right? It is more obvious if you look at it from this direction or maybe from this angle, all right? So like I said, half an hour ago, it is the ability for you to turn this in your head, all right? Now I'm turning it visually with the aid of the computer software, all right? So this is the foot of perpendicular from point E. You drop it all the way to the base, to the plane. That is point N, or you can see it from here. Point E dropped away from point N. And then that is the projection of E. And then you connect AN. That is the projection of AE. So it should be AN, all right? Okay? For those who chose AC or AD, all right? Perhaps you misdrop the projection, misdrop the point E, all right? You drop the point E here. You drop the point E here for those who chose AC and AD, all right? And I think it's fair because, you know, it's about half of us get it right. 1/4 of us chose AB, and 1/4 of us chose AC, and 1/4 of us chose AD. All right. AB 呢個就完全錯晒啦，得唔得？完全唔拉楞啦 ，right? I think AN is the right answer. AC and AD, they are not right, but still more or less correct. AB is way off the mark. All right. Okay, any question about this one? Now, based on this, let's do one more question, all right? And then I will tell you how to work on this software. Now, let me show you the next question and the last question today. This is it, all right? Now, once again, no calculation, just tell me, identify which is the angle between BE and the plane CDE. Now, the challenge is CDE is the sideways plane, all right? It's on the side. 喺側邊嘅，唔喺底嘅嚇。通常啲嘢喺底就容易啲嘅個 plane， 但係今次個 plane 喺側邊嘅。CDE is on the side, all right? Which is the angle between BE and the plane CDE? Now, this question is much harder than the previous one. Let me give you the answer sheet. All right, once again, no question. No calculation, just identification. All right. There are 3 ways I just mentioned to look at the projection. All right. First is imagine you are a bird. a bird watching above will have the line and the projection overlapping. Or imagine it is a lamp, a sun, that will cast the shadow on the ground. The shadow on the ground will be the line of projection. Or imagine you take the end point and you drop the foot of perpendicular. You drop the foot of perpendicular, all right? And you, on the ground level, you join the common point and the foot of perpendicular. Then you get the projection. Now, this is a difficult question, right? Much more difficult compared to the previous one. Simply because the plane CDE is on the side. Now, I'm going to, after we review the answer, I'm going to show you if we rotate the thing so that it is on the ground level, you will see better. I'm not going to tell the answer right now, all right? Let me give you more time for those who haven't decided yet. Only 26 responses. Let's start when we have 30, okay? 27, 28, 29. We need one more. 30, okay, good. All right, any more responses? Now I'll show you the result, all right? So I really want to copy this result, all right? 9 of us chose A, 5 of us chose B, and the majority, 60% of the respondents chose C, all right? Now let me show you the three-dimensional thing, shall we? The three-dimensional thing is like here. Oops, it's not here. It's on my computer. 27, right? It's here. Okay, so this is it. All right, we are talking about the line BE. All right, and the plane CDE. CDE is the triangular surface right here. All right, on the side. All right. Now I think things is much clearer if I rotate this 90 degrees so that the line BE is on top. All right, how do I rotate this one? Okay, I have some real problem rotating this one. Okay. All right. So that's why you have to turn it in your head. All right. Now, if I put CDE on the ground level, I don't think you will make that mistake anymore. All right. If I put CDE on the ground level, all right. If I put CDE on the ground level, now you can see the shadow of BE is in fact on CE. The shadow of BE is in fact on CE, not EN, not NE, all right? The answer to this question should be A, should be A. It is angle BEC. It is angle BEC, all right? If you recall the poll result, only 26 of us, only a quarter of us get it right. The majority of us chose C, maybe due to the previous question, right? The previous question, you are talking about point N. So in this question, perhaps it is also point N, right? But if you look at the diagram, it is not the case. The projection of point B, the foot of perpendicular, does not go to N. The foot of perpendicular for point E goes to N, all right? But the foot of perpendicular for point B does not go to N. All right, I think I have to share this video so that you can review this video, all right? Even though it is an hour-long video. The foot of projection for point B goes to C, all right? If you can look at it from this perspective, right? I think it's much clearer in this perspective, isn't it? If you drop the perpendicular from B all the way to the plane, imagine you have a light on top of it, right? Not on top of here, because now, not here, because we are now using this as the ground. So we have to put the light here, all right? If you put the light here, the line BE will drop the shadow on CE, not EN nor ED, all right? It drops the shadow on C. So the angle between the line and the plane is the angle between the line and its shadow. All right, write it down if you have to. The angle between the line and the plane is the angle between the line and its shadow on the plane. The angle between the line and the plane is the angle between the line and its own shadow on the plane. To find that shadow, you can imagine you have a light perpendicular vertically on top of the plane and shines the shadow on the plane. Or imagine you are a bird, all right? A bird will be like this, right? This bird is flying upside down. But anyways, we have this line BE overlaps with the line CE. It does not overlap with NE. It does not overlap with DE. The line BE overlaps with CE. So this is the shadow. Or imagine you have point B and you drop the foot of perpendicular all the way down to point C. Right? There are so many ways you can do that. But the first thing you need to do is to turn this in your head. All right? This was the original perspective. That was the perspective that misled 60% of us. All right? That was the angle of viewing that misled 60% of us. If I put the diagram in this particular, I can't recover it. If I put the diagram in this particular angle, I think that would be okay for many of us. All right. All right. So enough talking. Right now, I can let you do the turning on your own. Right. You can turn it in your computer or you can do it in your head. Now, I will give you the files that we use today. Right. I will share with you the files that we use today. And then perhaps I will give you one or two more exercises based on this one. All right. Based on the where question. Now, go to this website. The software is called SketchUp. It's one word. All right. The software is called SketchUp. All right. Now, I'll give you the version that is simpler than my one. My one is the SketchUp, the whole software that can help me to create the thing. All right. If you want to, you can download this on your own. But if you want simple things, you can do the SketchUp Viewer. This SketchUp Viewer is more simple. All right? It just lets you look at the 3D objects that I created or someone else created. You cannot mess up with it because you cannot change it. Right? It's like a PDF against Word, right? This is like PDF, the viewer. You can only read it. You cannot change it. All right. This web version is just like Word. You might accidentally change the thing if you are not careful. All right. You might accidentally draw a line or change things if you are not careful. All right. If you want to play safe, you go download this SketchUp Viewer. All right. The website is here, sketchup.com/download/all. Depends on where you are running, Mac or Windows. All right. There's no iPad version, sadly. All right. Go download the SketchUp Viewer. So let me switch to the SketchUp Viewer. Right. Now, do you see it? This is what you see when you start SketchUp Viewer. All right. In the SketchUp Viewer, the most important icon is this one, this orbit icon. All right. Now, this pen tool, this hand is to let you to move things around. All right. This orbit icon allows you to turn the things. All right. It's just drag and drop. You press the mouse button and drag the mouse button. So you are turning the things in three-dimensional space. All right. You drag this button. Okay. And then this hand is for you to move it around. This magnification glass is for you to magnify the object. All right. You don't have to worry about the rest. Well, you might want to if you are interested. But there are only these buttons that we use in this viewer. All right. You can turn the things around. If you want to open the file, just open the file. All right. I'll give you these 4 files in the Edmodo. Homework question 2, homework question 3, 2 and 3. And the 2 poll question that we just did. All right. A1 was this one. The plane is horizontal, it's on the ground level, so it is easy to cast the shadow, to cast the projection. And the majority of us fumble at this second question. For the record, it is the worst question we did in all this poll question for 4 days. 4 days, 3 days, all right? For most of the poll question, we did much better. All right, so far, this is the worst poll question. For the 9 persons who get the right answer, please congratulate yourself. Give yourself a hug, all right? It is a very good achievement that you managed to get this question right, all right? Don't worry if you are among those who chose the wrong answer, because now we discover the problem and so that you can improve, all right? It is better that we identify the problem and find a cure of it rather than cover up the problem and let the disease spread. But what I'm talking, sorry. All right, so all right, you can download this software and download these files I made for you so that you can turn this in at home, and then you have a better look at the object, all right? I will post on Edmodo several more questions and the corresponding files about this so that you can, on one hand, try to do the question in your head, right, without turning. Let me see, I can give you this. Where is it? Sorry, I can give you this. Okay. On one hand, you can try to do it like this. You can try to do it like this, all right? Just all mental ability, turn things in your head, all right? Once you get the answer, you can check the answer by opening the 3D object to see how good you are, all right? Or if you are not confident in it, you can you can fire up the 3D object right away and try to see if you can get the better viewing angle, all right? Is that okay? So I think it's time for today. Right, we have a challenge day. We have some challenge today. All right, so now the follow-up action, right? Think about the homework and make sure you get the homework right, all right? And secondly, follow up on the question I'm going to post on Edmodo, maybe later today, maybe this evening. Okay? And I'll get all the 3D shapes and the corresponding question so that you can think about the question and look at the shape, all right? If you want to, you can download this SketchUp Viewer software. Is that okay? So this is it. Let's call it a day. Thank you very much. You are prepared for the next lesson. I think next up is English. All right.